In example 5, we're going to write an exponential model when the initial value is not known. So we want to find an exponential function that passes through the points -2, 6 and 2, 1. So that means that one point that we can use for one equation of the form f of x equals ab to the x power, and the other point can also be written in the form of f of x equals ab to the x power. So if we take a look at the first point where it's -2 and 6, we know that -2 represents x, and we know that 6 represents f of x. So we can rewrite it in two equations. We can say that 6 is equal to ab to the -2 power. Now before we proceed, let's look at number 2. We have f of x again, which is equal to ab to the x power. So for the order pair 2, 1, we can substitute 1 in for f of x. And 2, let me change that real quick. 2 is the exponent. Okay? So what we can do is we can solve for a for either one of these. Okay? Now, we're going to pick the first one. It doesn't matter which one you choose to use. So we're going to solve for a. And by solving for a, we're going to divide both sides by b to the -2 power. And then we're going to rewrite this using exponential laws. So b to the -2 is the same thing as b to the second power in the numerator. So a is going to equal 6b squared, and then we're going to have to substitute what we solved for a into this equation for a to be able to solve for b. So let's go ahead and proceed. Now again, because we don't have the initial value, we substitute both points into an equation of the form, and then solve the system for a and b. So again, we get 6, which is equal to ab to the -2. 1 is equal to ab squared. Now again, we're using the first equation to solve for a in terms of b. So we divide both sides by b to the -2, and then using the properties of exponents to rewrite the denominator, we have a, which is equal to 6b squared. So now our next goal is to then substitute. So we're going to substitute a into our second equation. So this is what a is equal to, which is highlighted. And that means that this a value is now going to become 6b squared. And we're going to multiply that by b squared. And that's going to equal 1. So ultimately, when you multiply this all out, 6b squared times 6b squared is equal to 6b to the 4th. So 6b to the 4th is equal to 1. So in order for us to solve for b, we have to divide both sides by 6 and then raise both sides to the reciprocal of the exponent of 4, which is 1/4. So now b is going to equal 1/6 to the 1/4 power. So now we're going to go ahead and then simplify that. So we're going to get b, which is approximately 0.6389. So let me show you how to do that on a calculator. Okay, so the base is 1/6. So you're going to have parenthesis, you're going to put in the fraction 1 divided by 6 with a parenthesis. And then you have to find your exponent button. Now sometimes it'll say x to the y or y to the x. On this calculator it has an up arrow key. And then again in parentheses, you're going to put in the exponent, which is 1/4. So 1 divided by 4. And then we're going to hit enter. And it's going to give us 0.6389, which is our answer. So now we're going to substitute this value that we got for b back into the first equation to solve for the value of a. So a is going to equal 6 times b squared, which is approximately 6 times 0.6389 squared, which is approximately 2.4492. So we were able to find out what is the value of b and what is the value of a by using those 2 points. And then we can graph our model to check our work. And notice that the graph in figure 4 passes through the initial points given in the problem, -2, 6, and 2, 1. And the graph is an example of an exponential decay function. And the reason why it's decay is because if you look at the left side of the graph and you're moving to the right, it's like, think about a roller coaster. You're going down, so it's a decreasing function.